Hey everyone. In today's lesson, we're going to take a look at how to solve a couple of different types of compound inequalities. This first one here, you can solve a couple of different ways. This one is going to be an intersection. So the first way you can solve it is as just all one compound inequality, where I'm just going to try to get my x in the middle isolated. So what I could do here is I could add 5 to all parts of the inequality to get rid of the 5 in the middle, the minus 5 in the middle. So we get 2, an x, and then a positive 4. Okay, what this is saying is that x is greater than 2 and x is less than 4. Okay, so the way to graph this is I would put my open circle at 2. I would also put an open circle at 4 because both these inequalities do not have a line underneath, and I'm shading everything that's in the middle because those are the numbers that are in between 2 and 4, where x is greater than 2 and less than 4. You could also write this using the interval notation. Okay, it would look something like that, where you'd have 2 and 4. Okay, both regular parentheses because they're open circles. Now, a second way you could solve this, you could also, if you'd like, break it into two separate inequalities. So you can break this into two different inequalities. You could do -3 and then x minus 5. And you could also do x minus 5 and -1. And then just solve those separately. You'd still get the same answer if you were to do this. And the graph would be exactly the same. Your solution would still be the same. All right, let's take a look at a second example. Okay, now this one, you see that it's separated by an and, or an or, whereas the first one would have been separated by an and if you split them. Okay, an or is going to be a union, so you're going to solve each of your inequalities separately, and then you are going to plot it, and then we'll look at how to write the interval notation after. Okay, so let's solve this. First thing on this side, I would subtract 9 on both sides. I get 2x less than -2, divide by 2. And I get x is less than -1, so that's my first inequality. My second one, again, subtract 7 on both sides. I get -5x less than -15. Divide by -5, divide by -5, and I get x is greater than 3. Keep in mind on this one, I flipped the inequality this time because I divided by a -5. Okay, so let's go ahead and graph these. We have two separate inequalities that we're graphing on this number line, but it's a union, so we're graphing both on the same number line. So we have x is less than -1, so I'm going to put an open circle at -1, and we know that it's less than -1. We also know that x is greater than 3, so I'm going to put another open circle at 3, and it's saying greater than. So notice on this one, even though there's no overlap, there's no intersection, because it's a union, you're plotting both of them. Now this one to write in interval notation is a little bit different. You're going to have to use the union sign here, which is like a U, just like that. Okay, intersection we talked about is an upside down U, but we did not have to use that to write the interval notation for this one. All right, so my left side, we see that it's going to go from -infinity, okay, to -1. And then the union of that, okay, is going to be from 3 to infinity on the other side. Okay, so that's the union of these two sets. That's how you would write that in interval notation. Okay, so the solutions we have are here. Okay, we graphed it up here, and we also wrote the interval notation on the right. Okay, so that's pretty much the two main types of compound inequalities. Okay, again, we have the intersections that are separated by an and statement where you're shading in between most of the time. And also we have the union here where you're looking at the two different solutions on the same number line because it's the union of your solutions.